Hey guys, and welcome to one more episode of Builder Nation. For today's agenda, we have Anthony DiMare, co-founder and CEO of Bedrock, a company that develops autonomous underwater vehicles in order to explore, map, and classify the ocean floor. Welcome, Anthony. Super happy to have you here today.
Well, yeah, thank you. Excited to be here. Pumped to talk about robots and seafloor data and whatever you want to. So my name's Anthony DiMare, CEO and co-founder of Bedrock. I have a super nonlinear journey. I started off as a mechanical engineer. I worked in medical devices, then consumer electronics, was the first engineer at two different startups before starting an additional company before this named Nautilus Labs. That company was a maritime software data optimization platform for commercial ships at sea. And the whole goal was to build a cloud platform to bring disparate data sets from commercial ships, market information, different things that were happening on land to try and help optimize what a ship should be doing on the ocean to ideally save on or reduce fuel emissions while increasing profits for different ship owners. So that company, left that company in 2018 and got the opportunity to call up one of my an old friend, Charles Chow, who's now the CTO and co-founder of Bedrock, who had 15 plus years of robotics experience. We got introduced by an investor that said, you two are both ridiculously obsessed with the ocean in like weird ways, and you should just meet each other. And Anthony, you're doing data stuff, and he's doing autonomous robotics, and has worked on submarines, and you two should just meet. And so I called him up and said someone needs to solve this whole ocean exploration problem. Like, we had a bunch of space companies at the time. This was like end of 2018, early 2019. And do you want to try to crack it? Like, do you want to see if we can figure it out, at least from a technical point of view? Like, is it even possible? And then look at if it makes business sense to even do, and all of those things. Like, could we get to a place where the world could have, and this is kind of the pie in the sky goal right now with Bedrock, is like, do we have an ocean map, an updated ocean map about once a year? And so we actually started by approaching it from top down. So we looked at and designed a full ocean data collection, data interpretation, data access system. And we looked at the unit economics of that, realized that there was some pretty great, there's a lot of money to be made if you did it well, and a lot of technology would have to be built, but nothing that hadn't already been sort of figured out in other spaces. And we just needed to sort of put it together to make that possible for the ocean, and then worked our way back down to kind of what we have today, which is a data company. And so we're in this place right now where we can sort of operate our own vehicles, our own fleet, which we've designed ourselves. And then all of that data from our collected vehicles goes into our own proprietary cloud platform that helps sort of expedite and increase the speed of which you can sort of turn around that data. So any data that comes off has to get kind of cleaned and processed and interpreted, and that can take months right now in current processes. And then we end up in a place where we really accelerate the rate that any developer of ocean infrastructure right now, offshore wind, can gain access to, and then therefore develop offshore wind projects. And this could be applied broadly across any ocean infrastructure or development or remedy, or you name it, right? This is like the core. This is like buying property. The first thing you do is you go do a survey of the property to figure out what you just bought, or you do even before you buy it, ideally. So it's a similar thing in the ocean. And yes, that's a little background on myself and the company, and happy to take it wherever you want from here.
Talking about seafloor exploration, it's kind of like a new field because most of the people are focused on space. So how hard was it in order to build up another company related to this topic?
Hard. Yeah. So any like building a company is hard.
General.
Building a hardware company is really hard. And then building a hardware company that also has to operate in the ocean is like
really hard.
It's like really hard. Yeah, it's like much harder. Even to the point where like we don't really know how hard it's going to be yet. Sort of hard, right? Because no one is actually, so there's now rocket companies, and so people have done that. No one has built a pervasive ocean exploration, ocean mapping system yet. Like even the government doesn't have something like this. So this is like complete white space. So we don't really even know how hard it's going to really be. So I would say this one is, and then also we had this sort of unfortunate luck of like starting it in January of 2020. So 3 months before the pandemic. And so then trying to do that while also, you know, dealing with that. And then you have to build a company with hardware and, you know,
Hard.
Just hard. Yeah. Hard is I would use hard as like a really good word to describe what it was like, but, you know, fun and fulfilling.
But like at the beginning, I think people normally wouldn't consider to put money into this kind of project since it's new, if we can put it like that. But like, how did you raise like $4.5 million in the pre-seed phase? Like, how do you get investors at the beginning?
Yeah, I mean, so we raised about 8 million in our seed, and we looked for people that were looking for contrarian bets, who I think were, you know, I don't actually think it's that crazy when you look at, you know, right now in today's world, people pay about $7 billion a year for surveys. That is the size of the rocket launch industry, right? And we've invested billions and billions and billions of dollars into the rocket launch industry, right? Now, maybe that industry is growing, but it's growing, you know, at X number, it's at X rate, right? Ocean is just like starting, right? Like we are just beginning what I think many are looking at as a complete infrastructure revamp of everything we have on land. And a good portion of that now is including just supplemental infrastructure in the ocean. And the reason for that in general has mostly to do with we're running out of land around our metropolitan areas. And most of our metropolitan areas are close to the ocean, where we have lots of land or lots of space. And so what we're seeing is actually this sort of new nascent shift where even if we don't ever change the way people buy or consume seafloor data, like we're in a very new nascent space. And I think people in general are looking toward, you know, long-term solutions around how do we understand climate modeling and how do we get to a place where we can reliably, and, you know, this is a big point of, this is something that we deeply think is important at Bedrock, is how do humans find a way to work with the ocean to sustainably use but not destroy it. In other words, it's always been like the lung of the planet, and we have basically always just taken from it and without really understanding the detrimental aspects of what we were doing with it. To be able to even get to a place where one could conceivably say we are going to sustainably work with the ocean, or hell, maybe we're even just like leveraging the ocean to do what it already does, just do it better than what it's already doing to help our own existence on Earth. You would need a really deep core understanding of what was going on. And in today's world, that is not the case. And at the time, I don't think the pitch was actually that different. It was just, you know, it was Charlie and I, we had built this big system in a spreadsheet, and we had said, you know, look at this. This is what we think needs to happen. And here's how we're going to start. And here's the kind of systems that we need to figure out. We need to solve the acquisition problem. Someone's got to build a better way to move sonars around the ocean, period.
Wow. I mean, all I have to say is that it's a really strong pitch. I mean, you convinced me, and I'm not even the investor, but like, I have so many questions regarding this topic. It's super interesting. It's super new. It's like refreshing, if we can put it like that.
Yeah.
But like, how are you dropping the prices down? Because I imagine that this whole process, since it's really long, you said like 6 to 12 months, depending on the client, like how expensive it is, how affordable it is, because I know that the US Navy already has something like similar, if we can put it like that, but the hardware is heavier and it's not the same, right?
Yeah, I'm gonna go from like I'll sort of explain the process now, and we'll start there, and then I'll sort of explain how we work, and you'll sort of start to probably understand some of the cost benefits and acceleration of timelines, all the stuff, right? So right now you've got this terrible permitting process that you got to go through. It's about 6 months. Then you got to put out an RFP. So you got to go to all the surveyors out there and say, listen, we're going to do a survey. Here's the area. Here's the specs that we want. Here are the deliverables. And then everyone creates a month to get, they basically have 2 months to create a proposal. They do the proposal. The company picks a survey company. Then they got to move the ship from, you get a contract. You got to move the ship from wherever the hell it is in the world. Sometimes that takes a month or two to get the ship. Maybe it's in Brazil and they're like, cool, we want a survey in the United States. And they're like, all right, well, it's going to take a month for the ship to get there. So yeah, we'll start the survey in a month. So the ship sort of takes its time, goes up, sails up to the new offshore wind area in the United States, off the coast of Mexico, whatever it is, right? They get to the site. Then they have to do all of the kind of HSC checks. They have to get all the crew on board. So there's like anywhere between 40 to 60 people on board each of these ships at any given point in time. It needed to both operate the ship, operate all the sensors, make sure everything's being collected correctly, do the processing overnight, check and make sure they're not running into any marine mammals, so whales, dolphins, sea turtles, anything like that. There's really strict regulations, at least in US waters, around protecting all different creatures, right? And the areas where we're building all of this new infrastructure is in these marine protected animal areas. So very important to be able to basically make sure you're not doing damage to those animals. And so you have to kind of keep watch, and it takes you, then you have bad weather days. So, God forbid, you've got a storm that comes through. All of a sudden, like you can imagine, this is your ship, and imagine that your cameras are the sonars on the bottom. Like when the ship is doing this, like you're not collecting good data. It's just bad data. It's just bad data, right? So you can't use it. So you just have to sit there and wait. So sometimes you'll just sit there and wait for a couple days, a week. And generally you assume about 30%-ish of bad weather days. So 30% of the time you're just like sitting out there. Waiting. It costs about $200K a day to run one of these ships. So you do the math. And then, and that's, now you've just collected the data. Now you have to clean it, process it with a geophysicist has to look at it all, interpret it, put all these different data sets that you collected together. Then it has to go to an environmental review company. Then it has to go to an archaeological review company. Then it has to go to the government for a stamp of approval. And then finally, it gets to the client, an engineer who can say, okay, I think I can put an offshore wind turbine right here. And then they got to do that every single year. And so it's about a 12-month process to go from I want data to I have data. And so that's how it works today. Okay. Bedrock, we don't have to go through the permitting process because of these sonars that we have on our particular AUVs. So that already just gets rid of that whole upfront sort of issue in general. We're much more environmentally friendly. We don't hurt marine mammals. It's all electric. It's a totally different sort of operational profile. The vehicles themselves are about, they're 7 feet long. They weigh a little over 100 pounds. They break up into two. You can fly them anywhere in the world, overnight air. There's no waiting time. We can use traditional shipping methods to get all of our survey equipment anywhere you'd like. So just already up front, you've just saved, that's like 6 months, just, gone. We also have we think in fleets. So you don't just have a single vessel doing, lines, or maybe you have a vessel that has some robots that have gone out from the mothership, they call in some cases. The vessel costs about $80 million. Each robot right now costs about $5 million. And then if you have any smaller support ships on the surface to sort of baby or like just keep watch of the robots underneath, it's another $5 to $7 million for each of those. So you start to add up the costs of the old way. You need about $100 million to begin. So that's just
a standard.
That's just CapEx. You haven't even done anything yet. You just got to buy a bunch of stuff. Okay. So you got to go get debt financing to go do all of that. And then now you have it. And so our method is we've completely designed our own system from the ground up. So, our vehicle cost, we can build 200 of our vehicles for the cost of a single ship, like that's the kind of
The
like,
main difference.
yeah, like that's the scalability difference on the just, if you needed to put money into stuff to go do this work, we're better. Hard stop. Then you look at how many vehicles we can deploy at any one time. And so you can now cover more area in higher resolution with cheaper sensors that don't damage marine mammals. So that's just better in every single way. Because the vehicles are launched from shore, they come back to shore every 24 hours ish, roughly. So that allows us to access land-based internet infrastructure. So we can get that data up into the cloud, where then all of those parties that I was talking to you about, where normally you would go from blank to blank to blank to blank, all just get immediate access. So everyone can see it. So it takes this like serial process and turns it into a parallelized process. So everyone starts to get access to the same information all at the same time. And that takes that 6-month data life cycle and can bring it down to a couple of weeks. Wow. So I don't know how much of that made sense, but
it made sense. It made sense. I mean, I know you're a salesperson, but I mean, you manage a way in order to make our audience understand like 100%. So amazing.
It's just tough. It's like the process is broken.
So your journey as a founder, you need to know everything, right? The whole process, that you have to be in sales, you have to be, just like you said before, in marketing, in the engineering part, like with the clients. What would you say it's the part that you enjoy the most?
Well, so I'm a natural builder. So I like building stuff. So, I mean, there is nothing nothing better than building something and seeing it, or being a part of something and actually building, both digital, there's hardware and there's like incredible software, both on the vehicle and in the cloud. And like to see all of those things come together in one integrated system is nothing short. Like that's just like super fulfilling. So getting to even be a part of like helping shape and figure out how to make that happen. And I'm not the engineer on the ground doing it, right? Charlie's architecting, a lot of robotic systems, and we've got Todd helping architect the cloud systems and like being a part of that from a product perspective. So I'm very much a product person, but being a part of that from that part is great. I love storytelling, probably obvious at this point, but like I really like telling stories, and I really like trying to help people understand really challenging, tough things that normally no one would have any insight into. So I love the unsexy problems that kind of make the world go around. And so I love trying to tell good stories about those problem spaces, because I think those are kind of the areas where we're going to need to get a lot better in the next, I would say 100 years. If you look at wherever we are now, like no matter, you look left or right now, and it seems like a major critical systems are just failing all over the place. And like, they're kind of sometimes the things that sit in the background. And, so I love storytelling. Getting to work with really smart people on like a day-to-day basis is like nothing better than that.
Amazing.
I love sales. Like I like selling stuff. Like I like selling stuff that's of value, that provides value, that is a significantly better solution than before. So not sales for the sake of sales, but sales for the sake of actually solving real problems, and like getting appropriately compensated for doing that. That there's nothing for like, that's fulfilling for me. I can confidently say that every morning I wake up and I'm working on a problem that needs to be solved. Like there's unequivocally absolutely there's like never, I've never woken up being like, oh, like, wow.
Another day at Bedrock. I don't want to do this anymore.
Wow. Yeah. Like, shit. Like, am I just, supporting a system that doesn't really like, it's an incremental change. Like this is like a step function change, kind of play. And so, that's just super, that feels good.
How many people do you have at Bedrock right now?
We're about 31 full-time, with about another 20-ish contractors. So it fluctuates depending on the week, but it's anywhere between like 40 to 50 people on a sort of monthly basis at this point. And frankly, there's some of the best, they're the best engineers I've gotten to work with in my career. So just, following Slack channels on, electrical engineering and the mechanical engineering decisions and the autonomy systems and the cloud systems and weird nuances of like seafloor data that you would have never, like never thought of before. And I use this like consistently learning is another aspect of what I love about getting to be in the position I'm in now. Is like, boy, did I like we're still just scratching the surface. There's so many more layers down of information that we just, and I don't mean, I don't even mean that in a punny way. I just mean that like literally there is so much more that I feel like it is to be learned about how systems like this will operate. And so it feels cool to be sort of at the forefront of that as well. So I don't know. There's a lot. I'm excited about.
I'm even
biased,
excited,
right?
and I'm not even there. Imagine.
I'm biased, right? I'm biased. It's
Yeah.
it's awesome. Yeah, I could keep going, but I'm not going to.
Okay, I have two main questions regarding this specific topic. Like you mentioned challenges, right? Like, what do you think is the biggest technical challenge that you have ever solved since you started Bedrock?
Ooh, I wouldn't say that I've solved. I would say that the team has
The
solved.
team, yeah.
And I would say like the reason I'm having a hard time answering that is we started with we started the company assuming that we would be able to have like a good chunk of the vehicle be commercial off the shelf. And we would have to do a couple of things that were core technology developments that would be needed, but we could operate with a bunch of different systems. And it turns out like as we started to integrate those systems, as we started to test those systems, like we literally just kept like pulling a commercial off the shelf system off and would have to go figure out how to go build it ourselves. So like a battery, for example, like we bought one and it didn't work the way we wanted it to. And so we had to build our own. So now we have our own custom battery. The propulsion system started with something off the shelf. That didn't work. And so like, it just literally didn't work. And so we were like, go try to buy another one, or we could just build our own. So we ended up building our own, which is why you see, an X-Wing configuration with 2 thrusters, like that's all now custom us, right? And that's got its own sort of power management system and control system all itself. And then you look at the antenna, and we tried to buy an antenna, and we're like, this doesn't have all the different radio frequencies we want, the way we want them. And we couldn't tune them. And so we ended up, we were like, oh shit, okay. Like, I guess we
have to build our own.
we got to build our own. And like, and then we were, we're looking at how are we going to do, what is the ideal perception system look like for a subsea AUV? And like, how do you fit that into a small form factor? And like, okay, like, I guess we had our own sort of supposition. I'm not going to go into too much depth there, but like solving perception subsea, hard. Like it's really hard to see things underwater. You got to use sonars. There's some other clever things that we've done, but like that was a tough one. Being able to then incorporate all of those new technologies together in one integrated system, while also having it be something that can be flown everywhere, easily serviceable. Since we own and operate our own fleet, we actually are the customer of our own robotics, like our own robotic development. We are the users of our own robot. We don't sell our robot. No one else can buy it. So it's in our best interest to make it as easy to operate as humanly possible. But that's a whole nother layer of difficulty of, sometimes you would say a design is easiest this way, but maybe it's really hard to take out in the field. And so you have to design it a different way so that you can, it makes it really simple to service in the field if something goes wrong or something needs to be replaced. So everything's got to be kind of modular. So then you add a modularity problem on top of an already like custom built problem on top of all these other systems. And then you got to build software that makes all of that work together in a small form factor that has to compete with something that would be on the form factor of like a 2-ton, 20-foot long, maybe 30-foot long AUV that, requires a crane to move, and or a $80 million ship. And you're competing with like this system has to be able to collect data that system would be able to do. And so you layer in all of that, and I don't know which one is hardest. I don't know which of those is hardest. And then that's not even talking about the technical cloud problem where
That's just hardware. I
That was
mean,
just the hardware. That was just the robotics side.
oh my God.
And then you got to build the autonomy system for, subsea obstacle avoidance. And then, that never stops, right? Just like autonomous cars, like that technical development hasn't, that'll just continue to get better and better and better, but that never stops. Yeah. I don't know if I could pick one. Some of them involve more like engineering disciplines. Some
Okay.
of them involve, some of them went really deep into one discipline of solving like a really interesting problem in the EE space or the battery space or the mechanical space, or there's elegant designs across the architecture of all the different systems. And I don't know which one is I don't know which one I'm most proud of per se, but they're all needed, they're all needed to pull off what we're trying to pull off.
I know that challenges will keep coming, and that's part of being a founder and a co-founder and being out there and developing your own company. But I mean, Anthony, if you don't mind me asking, like, how old are you? Did you ever imagine at this point of your life end up being the co-founder of this kind of company, of Bedrock?
No, so I'm 30. No, I did not. That was not a. I didn't grow up. I mean, I grew up thinking like, oh, it'd be cool. Like I
You
read,
have.
I read Jacques Cousteau, and right, you read 20,000 Leagues Under the Sea and Jules Verne, right? I read all those as a kid, and I thought it was interesting. And I was a naval, I did stuff in my life, but no, I did not. I did not. I didn't think that this is where it all would go. I think I just like solving problems, and and so I think at the end of the day, like when you're building anything, it's like, what problem space are you solving, and does it make you happy and fulfilled? And
It's not your thing then.
yeah, it's like there are multiple layers of complexity, both technical and now we're in this fun phase where I'm really focused on making sure we've got the right people and the right organizational design to scale. Scale for us looks a little different than just a typical SaaS company or something like that, right? We want to be able to deploy fleets of vehicles from anywhere in the United States, by the end of this year, right? Like, so building a company that can accomplish that while also doing the real R&D work, while also building up production. So that's another thing that we're doing now, is we're building a production facility to basically assemble our own vehicles. These are all new things. Like we just try to find people that have done them before, and then we bring them to the company and let them do what they do best. And that is that's all a company is at the end of the day, right? So we're just doing that, and I think being thoughtful about how those people get put together and how you structure them and how you kind of create good communication flows between them, and making sure that you're catching those mistakes
On time.
like before you think they're even a problem. And
Okay.
then like I think that's something we've gotten really, really good at, is shifting quickly, oftentimes before there's an obvious problem. So we've gotten very good at that. Part of that, I think, again, there are multiple challenges, I think, to remote work for a company like this, but at the same time, all of the infrastructure around the way we've done engineering, the way we've done business, the way we've built hiring, the way everything had to be done in a remote first way. We're now coming back into a hybrid model, but it actually, that blends quite well to what we need to be able to do operationally as a business, which is deploy these things anywhere in the world. And so scaling up what we already have, it's not like we have to go back and say, oh shit, we got to relearn a bunch of stuff, or we got to change it, or we got to build something totally new. It's like, we're already a distributed company that's been doing distributed robotics development, cloud software development, distributed sales, so that's already in place in a lot of ways. And so we're probably have a little bit of an advantage there because we've just started during the pandemic, essentially. So that was a ancillary like benefit. But no, I would not have said this exactly where I would have been. Even if you had asked me, what is it, 2022? So yeah, if you'd asked me like 4 years ago where I would have, would not be here. Yeah, no.
Well, I'm glad, and I'm glad that you're enjoying it. I mean, besides everything, it sounds like you are super excited and super proud of what you have built, not only with your co-founder, but also with your team, right? So I'm glad
Yeah.
that. Do you have any advice for future entrepreneurs or people in the industry for the future engineers who are listening to this podcast?
Yeah, I do. Work on hard, real problems. Like we have like way too many hard, challenging, absolutely must solve problems that have far too few people working on them. And I mean, like, I even mean this as like a rallying cry around like, we need the smartest people. We need anyone that has any like deep passion or interest in anything that has to do with like solving, whether it be sustainability solutions, whether it be re-architecting old systems, whether it be, I mean, you could look across the board, just pull up any Wall Street Journal, any New York Times, any Economist, and open to any page, and you'll find some problem that probably is worth, a ton of money to solve. We need more people trying to solve those problems. And so I think we're in like a golden age of anything that has an intersection or a vertical component, a vertically integrated component around hardware, autonomy, software, data, right? Like there's a lot of really interesting stuff there. So just start working or learning about those spaces. And I think, you'll find really interesting things. And maybe not the most popular thing at first. Like everyone, no one understood why, the ocean.
Why I started on ocean fluid.
Yeah, no, I mean, like my friend, like it was, everyone was like, dude, like, come on, really? Like,
what are you doing?
yeah, why that? Like, why? Like, there's no businesses here. There's no like, there's that like, there's no SpaceX here, right? So, like, why are you focusing on this? And it's like, well, there's a problem. So focus on the problem. Forget the other stuff. Start learning about stuff, and just get going. Which I think a lot of people have said before, but I can't reiterate that enough. That it's not the
That's the main basis, I think.
Yeah, there's nothing to do with like where you get to in it's 2 years. It's like making sure you just make a step forward every day. And I think that is another big thing, is everyone sees these like overnight, like, oh my gosh, how did you get here? It's like it's one step in front of the other.
I've been working on this for like 4 years of my life. Yeah.
It's been a while, and like we're still at the very, very early days. So yeah, I don't, work on hard things is what is my advice. I find it to be much more fulfilling if you can pull it off.
Okay, that's great. Thank you so much for sharing this advice. I'm pretty sure that it's not only helpful for engineers, but for everyone who's listening to this podcast. So thank you so much, Anthony. Thank you for being here today. Do you mind sharing your social media? Where can people find you?
Yeah, sure. So I'm on Twitter at Anthony DiMare. I'm also pretty big on LinkedIn because the maritime industry is big on LinkedIn. So just if you can search Anthony DiMare on LinkedIn, that's me. And yeah, those are the two ways that you can best get in contact.
Amazing. Thank you. And
Great.
remember, guys, that you can also find more information, interesting articles, or interviews like this one with Anthony directly on our website, ControlHub/builder-nation. We would love to hear from you. And once again, thank you so much, Anthony. This was amazing. Thank you so much for taking the time.
Thank you, Eliza, so much. This was fun. Hope you have an awesome day.